Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So today we're going to be talking about vectors and scalars. So what did you do today?
I, believe it or not, went jogging this morning.
Really?
I jogged 5 miles.
You jogged 5 miles. That's going to be an example of a scalar.
Why is that?
Because a scalar, a scalar is a physical quantity that has magnitude.
Magnitude?
What's
magnitude?
Magnitude is just a way of saying an amount, how much of something there is.
Oh, so the magnitude that I jogged this morning would have been 5 miles.
Right.
Because we all know I jog all the time.
Right.
Okay, because I'm that healthy. Alright, so I jogged 5 miles is a scalar.
Right. Because it doesn't have a specific direction. Because you didn't just go in one direction, did you?
I did.
You did? Okay.
I did.
What direction did you go?
I went north.
Okay. Well, then that is going to be a vector.
Oh. So I jogged 5 miles north.
Right.
Is a vector.
Right. Because it's got both magnitude and a direction.
A quantity represented by an arrow with both direction and magnitude.
So we drew a compass on the screen here so you can see. I'm sure everyone's seen a compass before. It's got the little magnet in it. You need a compass in order to know what direction you're going, and that's something you need for a vector.
So when we're talking about vectors, we always have to have a direction.
You always have to have a direction and a magnitude.
A quantity represented by an arrow with both direction and magnitude.
You know how I remember the directions on the compass?
How?
Never eat soggy worms.
Never eat
They're
soggy
kind of
worms.
gross. Been there, done that. Yeah.
I heard never eat shredded wheat, but
I like shredded wheat.
Okay, well,
It helps me jog.
Whatever helps you remember. Okay, so
This is a compass. Now, when we want to talk about vectors, we got to be able to add vectors, right? When we're talking about adding vectors, we have magnitudes.
Right.
And what is a magnitude?
It's how much there is.
Okay.
Alright guys, now we've come to adding vectors. Now how do we add vectors? Well, let's go ahead and give an example. Let's say I ran 5 miles, because you all know how much I love to run. Let's say I ran 5 miles north. We'll go this way, call that north. I ran 5 miles. Let's say Mr. Domboski this morning, he walked 50 feet just to get to his truck so we can get over here. He walked 50 feet north. And I ran 5 miles north. How would we add these together? Very simple. We just take that 5 miles and add that 50 feet to it. So total, it'd be 5 miles. Then we'd add that 50 feet to it. In total would give us a longer line. This line shows our direction. It also shows the vector. So if we add these two together, it'll be 5 miles and 50 feet. Just take this long vector here and add it to this vector here. And that's all you do. Alright guys, let's take a look at some of your guided practice. Now that we know something a little bit better when it comes to vectors and scalars, we're going to figure out which of these are going to be both vector or scalar. So, take a look at 20 seconds. Is that going to be vector or scalar? Does it have both a magnitude and a direction? Magnitude, again, just another fancy number for the word amount or number of. In this case, we have 20 seconds. That's how many seconds. But do we have an actual direction? In this case, no. So that's going to make this scalar. I'll write this down. And now that you have this, we can go on and move on to the next one. The next one says 5 newtons of weight. Does it have a magnitude and a direction? Well, we have our magnitude by 5 newtons of weight. Do we have a direction? No, so that makes a scalar. But weight. Literally, weight. Weight does what? Which direction does weight pull? If I take this expo marker and I drop it, which way is it going to fall? Down, right? And that's because there is a direction to which weight travels. And that's going to be that downward direction. And that's going to be a vector. And then finally we have 32 kilometers an hour north. Our magnitude, 32 kilometers an hour. Do we have a direction? Absolutely. We have north. So knowing that we both have magnitude and direction, that's going to give us a vector. So again, 20 seconds, just time. No real direction. So that's going to be scalar. 5 newtons of weight. Weight does have a pull, a direction, and that's going to be down, and that will also be vector. And then we have north. Direction. All right, guys, let's do some distance versus displacement work. Let's say this is the house, right? This is where we're from, our home. We have to walk 5 blocks to school. Fun, right? Having to walk all that different distance. Yay, we are happy people. Until we realize, oh gosh, forgot my homework. So you gotta double back and walk that 5 blocks again to get your homework. Now what? Well, we gotta get back to school, right? So we gotta walk 5 blocks back in that direction towards school. Direction. Well, now we have 2 questions. What total distance did we walk? Well, distance is going to be a scalar term, because distance is going to be a total amount. Well, in this case, we walked 5 blocks one way, plus 5 blocks the other way, and turned around and walked 5 blocks more. So total, we walked 15 blocks, and that's going to be your distance. But our displacement, again, displacement is going to be how far away we are from our starting point. Our starting point was back at home. Our ending point, where we finally ended up, was here at school. And that's going to be a total of just 5 blocks. It doesn't matter how far you went forward, backward, forward, backward. It's where you started and where you ended. And that's going to be your displacement. And that's it.
Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude.